Hey, true believers. This is Mr. O'Donnell back again for Check This Out Mathematics. And if you're watching this video, give it a thumbs up. That's a like. And subscribe to my channel. And leave some comments down below. So let's get into today's episode. And let's say that we're going to revisit Pythagorean triples. I've been doing a series on logarithms for a while, and I've been taking some time away. But we're going to be back here with this third generator, part D, formulas that generate Pythagorean triples. And let's remember what Pythagorean triple is. Pythagorean triple is an A, B, and C value from the natural numbers, from the counting numbers, 1, 2, 3, and so on. And where you have a right triangle, and you remember the property of right triangle, this Pythagorean theorem, a squared plus b squared equals c squared. And so if we have some whole numbers that fit this theorem, like 8, 15, 17. Let's see. Let's write that down. Okay. You already know that these things are somewhat ad-libbed here. So, if we have A, B, and C, and that's 8, 15, 17, this is a Pythagorean triple, because when we say a squared plus b squared equals c squared, then this means that 8 squared plus 15 squared is 17 squared. And just to see that this is all good and true, 8 squared would be 64. And 15 squared, that's 225. And 17 squared is 289. So we're doing 8 times 8, and 15 times 15, and 17 times 17. You see that? And when we add 64 and 225, let's see. Oh, yeah, that's 289. It is. Okay, so you see, we double-checked that, and it's true. And so 8, 15, 17 is an example of a Pythagorean triple. And 8, 15, and 17 can be the sides of a right triangle then. And we have many Pythagorean triples up here on the backboard here. Where's that 8, 15, 17? Oh, yeah, right here. Here it is, 8, 15, 17. And so this is my 3, 4, 5 triangle here. 3 squared plus 4 squared equals 5 squared. And in this 3 squared, 4 squared, 5 squared triangle are all the Pythagorean triples that where the C value is less than 100. See that? See the C value right there? See the C value. Okay, there's another one. Okay, over here. Yeah, 91. Everything's less than 100. Okay, pretty cool stuff, right? Okay, so now previously we talked about these three formulas that will generate the Pythagorean triples. So not only is there the Pythagorean theorem, but there are formulas that generate Pythagorean triples for the Pythagorean theorem. And so if you have a value for m, and you say 2m plus 1 and 2m plus 2m squared, and then 2m plus 2m squared plus 1, you will get, plug any m value into this formula, and you will get a Pythagorean triple that fits the Pythagorean theorem. And likewise for Euclid's formula right here, 2mn plus and m squared minus n squared and m squared plus n squared will generate a Pythagorean triple for the Pythagorean theorem. And here's another generator of Pythagorean triples. If you have an s value and a t value, and you plug it into this arrangement accordingly, well, then you will also get a Pythagorean triple for the Pythagorean theorem. And now this last formula that generates Pythagorean triples came from, or actually is a version of Dickson's method. And Dickson's method says if you pick a P, a Q, and an R, where P squared is equal to 2QR, and then you add them in this manner, then you will generate a Pythagorean triple. Okay, and so now what we're going to do is elaborate on Dickson's method. And we're going to call this Dickson's method resolved and resolved. Okay, you like that? Okay. Okay, so we're going to resolve it and resolve it, okay, because it's going to be in its finality, okay? It's going to clear everything up about Dickson's method, okay? Okay, so after that great introduction, hey, like, subscribe, and comment, right? Yes, that's a good idea. Okay. All right, so now, so what are we trying to say about Dickson's method? Well, if you may have watched a few other videos out there about Dickson's method, like everybody has, you know, right? Okay, then what you may find out, or what you might think, is that it's just a matter of picking a p value and a q value and an r value where p squared equals 2qr. And so let's suppose that we pick 6 for p, and let's substitute that in there. So we'll have 6 squared, and that will give us 36. Okay? And then the condition on Dickson's method is that when you pick a P, Q, and R for this arrangement is only true when P squared equals 2QR. So that means we must pick a P value and a Q value and an R value where this is true. And then when we add P and Q and P and R and P plus Q plus R, then we will get a Pythagorean triple. So we have to pick P, Q, and R according to this condition here. And so if I just happen to pick P as 6, then notice that this 2 here is already in the condition. And so I need a Q and an R that will make 2 times Q times R be 36. And so if I let Q be 2, like that, okay, then I'll have 2 times 2 is 4, and then 4 times 9 will be 36. Okay, and so that's how I'm going to pick my P, Q, and R as 6, 2, 9. And now this is not the Pythagorean triple. This is the P, Q, and R set that will generate a Pythagorean triple. To generate the Pythagorean triple, we have to say P plus Q and P plus R and P plus Q plus R. Okay, and so P and Q, you have to mind your P's and Q's, you know that. 6 and 2 there, that's going to be 8. And then P and R, 6 plus 9, is going to be, so that's 6 plus 2, that's 8. And then 6 plus 9, that's 15. And then 6 plus 2 plus 9 will be 17. Okay? And so by picking this combination of P, Q, and R, according to this condition, I have generated the Pythagorean triple 8, 15, 17, which we talked about just a moment ago, right? Okay, so we might have an idea that the way to generate Pythagorean triples for the Dickson's method is just to pick some combination of P, Q, and R such that P squared will be 2QR. Like this combination gives us 36. And the other side also gives us 36. But actually, we don't just pick something and see if it's going to work for the P squared equals 2QR. We don't just pick some numbers and make sure that it works for this condition so that it'll work for this Pythagorean triple. There actually is a way to find the P, Q, and R combination for every Pythagorean triple. So we don't start with this condition, actually. We actually start with this idea of how to find the right p-value. Okay? Now I do want to make one point here, that the p-value, you see how this 2QR? Well, since this QR is multiplied by 2, then 2QR is even. Okay? And so if this is even, then P squared is even, because it's an even number equal to an even number. And the only way to get a squared number that's even is if the p-value itself is even. So if you want to make an even squared number, you have to have an even root. So the p has to be even, and then p squared will be even, and then it will be equal to 2QR. Okay? And if it's not even, well, then it's not even going to work. Okay. All right. So so p has to be an even number. Okay? And so let's show how we can always find the P and the Q and the R value from the Pythagorean triple, A, B, C. Okay. I have too many slides here. I got to get a dry erase board for this back. Or maybe off to the side here, I'll have a dry erase board. That's coming. Okay. I found one that I liked. Okay, well, I didn't find it. A friend of mine found it. Okay, friend of mine. Okay, very important friend. Okay, so Okay, so what's next on my list here? Okay, so here's how you figure out the p-value. The p-value is found by taking the A and adding it to the B and minusing the C. That's how you find the p-value. And I believe I did this in a previous video. That's how I found the p-value. Okay, but I didn't elaborate on that much. Okay, and so let's take that example of 8, 15, 17 for A, B, and C. Okay, and let's substitute that in there. So A will be 8, and B will be 15, and C will be 17. And so then 8 plus 15 is 23, minus 17, and then P will be 6. Okay, and that's what we had here, right? I chose P to be 6. So now we were thinking that I just kind of chose 6 and made the other numbers work. No, actually it's not that way. We're going to show that it's resolved and resolved. And you don't just pick numbers that work for the condition. You actually pick the numbers according to this formula. And then it will work every time. Okay? And so now then, so if we take so the p-value is going to be 6 here. And so let's realize that the in order to make this become the a value, okay, which is eight. Okay, the a value is 8 there. That's what the a value is. And so in order for this p-value, which is 6, to become the a value, which is 8, we would just subtract 8 minus 6 and get 2. And so that means that we're taking the a value and subtracting the p value. And that's giving us the 2. Okay, and so then we'll have 6 plus 2, which will give us 8. Okay, and then we'll find the b value. See my notes here. The b value will be 15 minus 6. And so that, which is, no, the b value is not 15 minus 6. The b value is 15. And so the b value, which is 15, came from Okay, we had a short pause there. You know, that's what you do when things aren't working. You kind of pause and regroup. And, okay, let's look at it again. Okay, all right. So if we choose P by this arrangement here, if we take the as in this examples for 8, 15, 17, if we take the A, B, and C value and say A plus B minus C, that's how we're going to get the P value all the time by this arrangement. And so in this example, we're going to take the 8 and add the 15 and subtract the 17. And then 8 plus 15 will be 23. And 23 minus 17 will be 6. And so now then, we want to take that P value and create the A value, 8. And so that's easy enough. The A value is 8, and so if we just take 8 minus 6, we'll get the 2. And that's the Q value, you see? And so 6 plus 2 will be 8, because how did we get 6 plus 2? Well, we took 8 minus 6, and that gives the 2, you see. Think about it for a moment. It'll work. Okay. Yes, it's kind of confusing first. Okay. Okay, so then 6 plus 2 will give us 8 there. And then the R value can be found by taking the B value and subtracting the P value. So 15 minus 6 is 9, and that's going to be our R value. And then since we did 15 minus 6 to get 9, well, then that means 6 plus 9 will be the 15. That will give us the B value. And so B is found by taking the P and adding the R here. And then to get the C value, we say P plus Q plus R. And that's, well, that's Dickson's method anyway, right? Here it is, Dickson's method, P plus Q. Okay, here. Okay, you have to be very clever about this. Okay. Nope, you have to switch it. Okay. This way. Okay, there we go. Okay, so if you want Dickson's method there, then you have to do it according to this blue slide here. Okay, you can take your own pencil and paper and see that that works in your mind there. Okay. Okay, so now then, so if instead of just picking P, Q, and R according to this condition and arriving at a Pythagorean triple, because we picked a P and a Q and an R according to this condition, actually P, Q, and R are picked from the triple. Okay, we don't pick them before the triple. We don't pick them to get the triple. We use the triple to get the P, Q, and R. And so this is the formula from the triple that gives us the P value. Okay, and then if we realize what's happening here, if we realize what's happening, we did A plus B minus C to get us that P value, right? Okay, and so now let's realize that if we subtract the B value, subtract B, and we add C, and that means we're going to subtract B and add C on the other side, like that. Then these will cancel out, right? And A is going to be P minus B plus C. But that's not what you had, Mr. No. Okay. Just bear with me. Okay. And so now let's put this back here. A minus P. Okay, so I'm bringing this back, this P back over here. And I'm going to turn this around, and instead of writing negative B plus C, I'm going to put C minus B. Okay? And that C minus B is the Q value. And so there's two ways of getting the Q value. By subtracting the A value and the P value. Oh, hey, that is what I did, isn't it? Where did it go? Oh, yeah. Let's see. That's how I did get the Q value. I took the A value and subtracted the P value. 8 minus 6. A minus P gave me the Q value. Okay. And so there's two ways of understanding the Q value. The Q value is A minus B, and it's also C minus B. Excuse me, A minus P and C minus B. You got to mind your P's and B's too. Yes, you're an old-time printer there. Okay, okay. So now that's how we can find the Q value. Okay, now let's realize something else here, that A plus B minus C is P, right? That's how we get P. Okay, and so this time, let's subtract A and add C. Subtract A and add C. That's what... I'm a mathematician, and I study the theory of numbers, and so I'm a number theorist, and so that's what we do, is we move numbers around, okay, and we look at the underlying theory behind the numbers, okay, all right, so okay, so then this gives us the B. Okay, see, that's all that's left when the C's cancel out and the A's cancel out. Okay, the A's are going to cancel out, the C's are going to cancel out. All that's left is B, and B is P minus A plus C. Okay, and now I'm going to do the same thing I did before. I'm going to bring the P back over. Okay. And then I'm going to rewrite this as C minus A. And so you see, if I take B minus P, that's giving me the R value. And so there are two ways to understand the R value. It's B minus P and C minus A. Okay, and is that what I did? Let me see. Oh yeah, it is what I did. I took the B value, which was 15, and I subtracted the P value, which was 6. B minus P. There it is, B minus P, and that gave me the R value. Okay, R value. I think we use that in air conditioning or something like that, or air conditioning filters. I don't know, the R value. Okay, maybe somebody can comment and tell me what I'm talking about, because I don't know what I'm talking about, right? Okay, so now that's how we got the 15. Okay, that gave us the R value, and then we could go back and say 9 plus 6 and get that B value. Right? Okay. All right, so now, then the C value, is, let's start at the beginning here. P equals A plus B minus C, right? And so now we want to get the C value. Okay. And so let's add C to this side here. All right, let's actually move this over a bit. Got to move it on over. Use the George Thorogood principle. Okay, move it on over. Okay, so let's try this again. So P equals A plus B minus C. All right, and then we're going to, let's see if you see I moved it on over. See right there, moved it on over. Okay. Okay, now we're going to add C. And add C and subtract P and subtract P. Okay, you see we're going to add C and subtract P and subtract P. And that's going to give us C. See it? It gives us C, right? Okay. C equals, because the P's are going to go away there. And so then C will be equal to A plus B minus P. Yes. And then what we're going to do is realize that I can say C equals A there. Oh, what I'm going to do is I'm going to insert a P. And then plus A. Okay, so I'm going to bring a P into this expression. And if I bring a P into the expression, I need to take the P away. So then I'm going to put minus P and then plus B minus P. Okay, so here I have P minus P, and that's gone. And so by putting the P and the minus P here, I haven't changed this expression mathematically, but I have changed it such that I can say P plus, and what's A minus P? A minus P. I think we've seen that before. Oh, yeah. Come on. Okay. Get on up here. Get on up. Okay. So then A minus P is our Q value, right? Okay. Try to stand that up so it stays up. Okay. Okay. So A minus P is our Q value. And then B minus P, oh yeah, we've seen that before, B minus P, that's R, okay. And so you see how that happens? C is P plus Q plus R. Okay, so from this one idea of P being A plus B minus C, then we can find the Q value, which is A minus P, or C minus B, and the R value, which is P minus B, or C minus A. And then we can have our P and our Q and our R. The P and the Q and the R that gives us the Pythagorean triple. Hey, it's nicer to see me, you know what? Okay, there we go. The P, the Q, and the R that gives us the Pythagorean triple. And we can also realize that we have our A value. Where's our A value? Oh yeah, A is P minus B plus C. And then B is P minus A plus P minus A plus C. And then C is A plus B minus P. And that gives us the P plus Q plus R. Okay? So now, if you're thoroughly turned around there, get out a pencil and paper and write all this down and make it make sense to you. Okay? That's how you have to do math. Okay? Math comes from seeing and believing. You have to see it, and then you have to write it down, and then you believe it. Do you believe it? I believe it. That's how I learned. Okay. Okay, so now let's realize that if we do this, we're going to come up with a wonderful truth. Okay? A wonderful truth. Okay? All right. So here it is, the wonderful truth. P plus Q squared plus P plus R squared equals P plus Q plus R squared. That's Dickson's formula for generating Pythagorean triples. And Dickson's formula works if P squared equals 2QR. And so let's show that the way to get the correct A, B, and C value is to take the A, B, and C values to find P, and to find Q, and to find R. So how did we get P? We said A plus B minus C, and that gave us the P value. Okay. So let's substitute that in there. A plus B minus C squared. That's going to be our P value. Okay? And then 2, and the way that we found Q was A minus P. Okay, so let's put that in there. A minus P, right? What happened? Yes. Okay. A minus P was Q. Okay. And the way that we found R is we said B minus P, and that gave us R. So let's put that in there. What happened? Okay, B minus P is how we get the R value. Right here. B minus P. b minus p. All right, so we have p squared equals 2 times q times r. The way to find p is to say a plus b minus c, and the way to find q is to say a minus p, and the way to find r is b minus p. Okay. All right, now we're going to multiply this out. A plus b minus c squared. Okay. All right. Okay, let me make a correction on my notes here. Okay, there we go. All right, so the way to multiply a plus b minus c squared is to think of it as a plus b minus c. Okay, the a plus b is still there, and the minus c is there. But I just put these brackets here so that I could have regroup the a and the b. A plus b minus c is a plus b and then minus c. Okay. Okay, and then what we're going to do is we're going to square this arrangement by this formula. It's too many formulas, Mr. O'Donnell. Okay, well that's how math is. There's just too many formulas. Okay, get used to it. Okay, so here's our formula. X plus y squared is the same as x plus y times x plus y. And then if we distribute, that's x squared plus xy. See that? X squared plus xy. And then plus y times x, which is still x times y. I mean, why not? Okay. And then plus, so that's y times x, giving us xy. And then y times y, giving us y squared. And then x squared plus xy plus xy. Hey, there's two xy's. Okay, so let's be wise about that and put 2xy plus y squared. Okay, so if you want to square a quantity, x plus y squared, then this is the arrangement that you want. X squared plus 2xy plus y squared. Okay, so I want to square a plus b minus c. And the a plus b is going to be my x. Okay? The x here. Okay, and so then I'm going to put x squared. And so that means I'm going to put a plus b squared. Okay, and then I'm going to have, this formula also works if it's minus, so let's put it for minus here. Put a minus here, and a minus here, and a minus here, and a minus there. There we go. It's all minus. Okay. Oh, and minus here, right? Okay. There we go. So if it's x minus y, then it's x minus 2xy. And then a negative times a negative is a positive. See how that works? Okay. All right. So then we want to put a minus 2xy. So that's minus 2. And our x is the a plus b. And the c is the y. So x squared minus 2xy. minus, no, plus c squared. Okay, now, are you following me? If you can't follow the math, you can at least follow the channel, right? Okay. Okay. But you can follow the math. You can. Okay. All right. So now we have this a plus b. And so let's do that x plus y again. Okay. Yes. See, that's what we do in math. We do it again. Okay. That's what makes it so much fun and exciting. Okay. So we're going to have a squared plus 2ab plus b squared. Okay. And then this is a negative 2 and a c. You see that? Negative 2c. So it's going to be negative 2ac. Negative 2ac. And negative 2bc. Okay. Because we're going to distribute. We're distributing from the left and from the right. Isn't that exciting? Okay, just like that. Okay, distributing from the left and the right. The negative 2 times the a and the c times the a. 2ac. And negative 2 times b and c times b. There you go. Okay, exciting. Okay. Plus c squared. Okay, so that gives us the left-hand side expanded. Okay? All right. And so now let's put down the right-hand side just the way it is. So we running out of room here. We're living on the edge like Joe Perry and Steven Tyler, right? Okay. 2a minus p and p minus b. Okay, living on the edge. Okay. All right. So there's the, this is the expanded left-hand side, and we're leaving the right-hand side as it is, because I'm going to expand that on the next slide. Okay? All right. Here we go. This is exciting. Never been seen on YouTube before. Okay. Don't say you never wanted to see it on YouTube before, because that's just not true. Okay. Okay, so now we have a squared plus 2ab plus b squared minus 2ac minus 2bc plus c squared. Okay, that's the left-hand side. Okay, and that's going to be equal to 2 times a minus p and p minus b. B minus p. Is that what I said? Of course that's what I said. Okay. All right, so there's how we have it so far. And now I'm just going to work on this right-hand side. Okay. So 2 and a minus p. You see that a minus p? Well, instead of p, I'm going to put what p is. Right? P was this right here. P is a plus b minus c. Right? Okay. So A minus A plus B minus C. Okay, so instead of P, I put what P is. Okay, and now then B minus P again. That's A plus B minus C. Okay, now let's work on that a bit. Okay, so then we have 2. And now check this out, because this is check this out mathematics, right? Okay, so check this out. You see here I have A minus A. Those are going to cancel out. Okay? And then this negative carries over to this positive B. So a negative times a positive will be a negative B. Okay? So the A's are going to cancel out. We're going to have negative B. Okay? The opposite of positive B is negative B. And the opposite of negative C is positive C. So you see we have positive C. And the A's crossed out. A minus A. All right. Okay, now then, in the other expression, we have the B's are going to cross out. Okay, B minus B there. That's going to cross out. All right, and then we're going to have negative A, and negative times a negative is a positive C. So negative A and positive C. Negative A and positive C. All right, and then if we turn it around, it looks like this. But, oh, that's me. Okay. All right. If we turn it around, we say C minus B like that, and C minus A. Okay, so how this A minus P, well that was, where did that go? Oh yeah, here it is. Okay, it's over there. All right. So you see that this, which one? This one, yes. Okay, so I said that Q was A minus P. And that's true because it's right, where did it go? Oh, it's right here. Okay. Q was A minus P. Q was A minus P. Okay? And then look at what happened. That Q, that 2QR, is now 2C minus B. And C minus B is another way of writing Q. Okay, you see it's all coming together. Okay, and then the Q, the R, was B minus P. And then that became 2QR, which is C minus A. And C minus A was another way of writing R. B minus P and C minus A. Okay. See, that's working. It's all happening. It's happening. Okay. And so now then let's multiply here. Okay. So Anytime we have parentheses, we can make brackets, and anytime we have brackets, we can make parentheses. And we use brackets and parentheses to keep from getting mixed up when there's parentheses and brackets. You see, like that? Okay. So I'm going to write these as parentheses now. Okay, just whatever's convenient is what we do in math. Okay, so we have parentheses there. And now I'm going to say c times c is c squared. And then I'm going to say c times negative a, which is negative ac, which is what we do here in the winter. We don't run the AC, we run the heater. You know that. Okay. So no more AC. That's what it is. No AC. Okay. Okay, minus BC. Minus BC. Okay, back then, BC. BC, okay. Okay, have BC in you. Okay, and then negative B times negative A is positive AB. Okay? And then let's run that 2 through. Okay. Equals 2c squared minus 2ac minus 2bc plus 2ab. Running the 2 through. All right. Okay, so now, is this going somewhere, Mr. O'Donnell? Mr. O'Donnell always goes somewhere, okay? He doesn't know where he's going, but he goes somewhere. Actually, he does know where he's going. Okay. Okay, so now check this out here. Oh, yeah, that's my channel, right? Okay. Let's see. Oh, here's a 2AB. Oh, and there's another 2AB. You see that? Plus 2AB and plus 2AB. So when you have this something that's the same on either side of the equals, then you can cross them out. Okay? So a plus 2AB and a plus 2AB, those are gone. Okay, let's see what else we can cross out. Oh, here's a negative 2AC on the left side and a negative 2AC on the right side. And so those are equal. Equal things can go away. Okay? So negative 2AC and negative 2AC. Okay. All right, let's see. Oh, yeah, here's a negative 2BC on the left-hand side and a negative 2BC on the right-hand side. So equal things can cancel out. Okay. Hasta la vista, baby. Cancel them out. Okay, so now what do we have left? A squared and B squared and C squared. And then over here we have 2C squared. Okay, so let's write that down. This is exciting. Are you seeing it happening? It's happening. Okay. All right. So, actually I need that back. Okay. From the ground up. Back into my hand. Okay. A squared plus B squared plus C squared equals 2C squared. Okay. A squared plus B squared plus C squared equals 2C squared. Okay. And then we can subtract C squared here and subtract C squared there. And then we'll have A squared plus B squared equals And if I have 2c squared and I take away 1c squared, well, I only have 1c squared left. Okay, so this is true. All right, a squared plus b squared equals c squared. That's true. That's the Pythagorean theorem. And that truth okay, that's something that's true about a right triangle. And we have B, and we have A, and we have C, and we have a right triangle. A squared plus B squared equals C squared. And where did that truth come from? That truth came from this truth, that P plus Q and P plus R squared is equal to P plus Q plus R squared if P squared equals 2QR. And so we substituted in place of P, we put A plus B minus C, and we substituted in place of Q, A minus P, and we substituted in place of R, P minus B, and we went through all this fancy algebra stuff, right? Fancy algebra stuff, that's what we call it. Okay? On all of this fancy algebra stuff. And we got something else that's true. So now, Dickson's truth is connected to the truth of the Pythagorean theorem by this truth, that P is A plus B minus C. And so that's how you always find P. You say A plus B minus C. And then how do you find Q? You take A minus P. And how do you find R? You take B minus P. And that will always give you the P and the Q and the R. So you don't just pick a P and a Q and R and get the Pythagorean triple. You actually have the Pythagorean triple, and from that you get the P and the Q and the R. That's the Dickson's method resolved, and resolved. Okay? And so now we have P, Q's, and R's for every Pythagorean triple. Every single one of them. You want to see that? Here's all these glorious Pythagorean triples arranged on this Pythagorean triple itself. 3 squared plus 4 squared equals 5 squared. So on this 3, 4, 5 triangle, you got all the Pythagorean triples up to 100. The C value is always under 100. Okay? Under 100. Under 100. Under 100. Okay? Okay. And let's show that they're all happening. So, here they are. You want a 3, 4, 5 Pythagorean triple? Use 2, 1, 2 as your P, Q, U, and R. You want a 5, 12, 13 Pythagorean triple? Use 4, 1, 8 as your P, Q, and R. Okay? 5, 12, 3, 4, 5 up there. You see it way up there? And 5, 12, 13. You see? Okay? And then if you want a 7, 24, 25 triangle, Pythagorean triple, which is a 7, 24, 25 triangle, use 6, 1, 18. How did I do that? I took the 7 and I added the 24 and I subtracted the 25, and that gave me 6. Okay? Okay? And then if you want a 8, 15, 17, your P value is still 6, but your Q and your R value are different. If you want a 9, 40, 41, here's your P, Q, and R. See, it's happening. Okay, do the math. You can do the math. I don't have to do all the math. This is going to be 3 hours long if I do all the math. You can spend a couple hours doing some of the math. Okay. Okay, well, that's just a few of them, Mr. Gunn. Okay. Well, here's how to get your 3, 4, 5 triangle, right? From 2, 1, 2. Okay. So let's continue on that. After 3, 4, 5 is 6, 8, 10, a multiple of 3, 4, 5. And so if you want to get 6, 8, 10, you can take 6 plus 8 is 14 and subtract 10. 14 minus 10 is 4. You see, that's how you do you say A plus B minus C, and that gives you P. Okay? And so if you want the 6, 8, 10, here's the 4, 2, 4. Okay? And so then here's all your multiples of 3, 4, 5. And here's all the P, Q's, and R's that do. And how did I find them? Just by trying to multiply numbers together and see if it worked to get P squared plus equal to 2QR? No. I didn't just try to make a P squared equals 2QR. I used the formula for P. And the formula for P is A plus B minus C. Okay, so now 21, 28, 35 right there. There it is. You see that? Right there. Okay, now let's see. That continues over here. Here's your more here are more multiples of 3, 4, 5. And here are all the P, Q's, and R's that generate them. Okay. And then, do we have more? Oh yeah, we have 18 3, 4, 5 family. Okay. So, continuing on that 3, 4, 5 family. Here's more multiples of 3, 4, 5. Look up here. 42, 56, 70. Oh yeah, right here. 42, 56, 70. That's a multiple of the 3, 4, 5. Okay. And these are the P, Q, and R values that generate those triples. Okay, and things are getting a little bit erased here. That's what happens with the dry erase. They erase. Amazing. Okay. All right. And now then, let's go back to the next Pythagorean triple in our list. 5, 12, 13. Came from the PQR 4, 1, 8. See, 4 plus 1 is 5. 4 plus 8 is 12. And 4 plus 1 plus 8 is 13. And how did the 4 get there? 5 plus 12 is 17. Minus 13 is 4. Okay. All right. All of this actually is already known. It's been showed in other journals and my other mathematicians. I'm just bringing it to light. Okay. Okay. So, oh yeah, 5, 12, 13. Okay, here's the multiples of 5, 12, 13. Okay, where are we? Oh yeah, we're in my apartment here at my studio. The Check This Out Mathematics Studio. Aren't you glad to be a part of that? Okay, so here's 5, 12, 13, and these are all the multiples of 5, 12, 13 here. Okay, and so here's how to get 10, 24, 26 from P, Q, and R, and how to get the other multiples from the other P, Q's, and R's. Okay. And that takes us up to 91 there. Okay, so 5, 12, 13 is finished. Okay, the next one is 7, 24, 25. right here, which came from 6, 1, 18. Okay. And so 7, 24, 25 is right here, this family here. You see how that? Down, down, down. Okay. And so 7, 24, 25 came from 6, 1, 18. And then here are the multiples of 7, 24, 25. And here are the P, Q, and R values. Notice that they're multiples also. 6 times 1, 6 times 2, 6 times 3. 7 times 1, 7 times 2, 7 times 3. See, it's happening. It's all there. Okay, and right next to 7, 24, 25 is 21, 29. 20, 21, 29. So let's do that one while we're at it. Okay, so 20, 21, 29 came from this P, Q, and R. And then here are the multiples of 20, 21, 29, and the multiples of P, Q, R that generate them. Okay? All right. Then slide number 11 here. Okay. That's the 8, 15, 17 family. Right here. 8, 15, 17. 6, 3, 4, 5. 5 members in that family. Okay? And so if you want the 8, 15, 17, this is the PQR that will generate it. And then if you want the other multiples of 8, 15, 17, here are the PQs and R that will generate it. Okay? All right. Okay, and then if you want the 9, 40, 41 Pythagorean triple, that's this one right here. There's 2 of them in this family where all the members of the, where all the digits in the family are less than 100. Okay. And so then 9, 40, 41 and 18, 80, 82 are coming from these P and Q's and R's. And then we have 12, 35, 37. Those 2 in this family. And here they are, 12, 35, 37, and 24, 70, 74, and they come from these P, Q's, and R's. Okay. And then now we have all the primitive. Well, the primitives are 3, 4, 5. That's a primitive. That's a beginning Pythagorean triple. And then you have all the multiples. So 3, 4, 5, and 5, 12, 13. That's another primitive. And 7, 24, 25, and 8, 15, 17, and 9, 40, 41, and 12, 35, 37, and 5, 12, 13, oh, and 7, 24, 25, I think I said that one. And then this one, and this one, and this one, and then the 20, 21, 29. Those are all the primitives that have family members, where the family members are under 100 there. But now here are these single primitives in this red frame group. Okay, you see how I got little picture tabs here? So they're its own. Okay. Okay. So in those primitive single member families, here they are. You want the 11, 60, 61 right there? Okay. There are the P, Q, and R's that generate those primitive Pythagorean triples. And then there's, so that gets us this one, this one, this one, and this one. And then What happened? Oh, we're going down. 11, 13. Oh, yeah, I wrote some of them twice. Okay, who cares? All right, so I have, yeah, I put 12, 35, 37 in there for good measure. Okay, that's all right. And there's the 21, 20, 21, 29 again. Okay, all right, and then here's the 28, 45, 53. That's this one here. Okay, that's in our list. Okay, and then this is one of my favorite Pythagorean triples. Who has favorite Pythagorean triples? Okay, Mr. Donald does. Because see, this is palindromic. You see, it's 56, 33, 65. So 5, 6, 3, 3, 6, 5. Reads the same way forwards and backwards if you read it from the middle. Okay. Okay, and so that's right here. 56, 33, 65. A palindromic Pythagorean triple. Okay. All right, and then here's the rest of them. Okay. So I have shown you that all of these Pythagorean triples have come from P, Q's, and R's. Okay. And those P, Q, and R was from the idea that if I want P, that's A plus B minus C. Okay? And so, and anyway, so how do you find P? You just do A plus B minus C. So if you have a Pythagorean triple with an A, B, and C, you can add them and subtract them, A plus B minus C, and you can find P. And then once you find P, you can find Q and you can find R. So it works for all Pythagorean triples. But you don't just try to pick something from that fits the condition. You have a formula that you can use all the time. P is A plus B minus C. And so now there's no more wondering which numbers to pick to make P squared equals 2QR. Just find P according to A plus B minus C. That's it. Okay, that's Dickson's method, resolved and resolved. No more to say about it, but I'll probably find some ways to say more. Okay, that's what I always do. Oh, don't move the computer there, Mr. Donald. Okay, stay. Okay, all right. So this video has been the longest of all time. But that's good. We had fun, right? Okay, so that sums up this third generator, part D, of formulas that generate Pythagorean triples from the where's my check this out mathematics? Oh yeah, right here. From check this out mathematics. That's me. Okay. You like my square root of C there? Okay. And so, hey, like this video, subscribe to the channel, and leave me some comments, and watch all my other videos. See it all tied together. And then the logarithms, and then we're going to do some more fun stuff. I'll have content coming out my ears like Shrek, okay? Like Shrek's earwax. Okay. All right, true believers. This is Mr. O'Donnell signing off. Come back for more fun. Okay. This is this channel to binge, right? Yeah. Okay. All right. Hasta la vista, baby.